Okay, today we're looking at 6.6, which is rational exponents. We're going to be able to write expressions with rational exponents in radical form and vice versa, and also simplify expressions in exponential or radical form. So the other day when we were talking about how we input bigger roots into a calculator and I taught you to do them as a fraction, that's essentially the same principle that we're doing today, that anytime we see something to a fraction, that's how it's represented as a root. So we have our rational exponents. Your bottom part of your fraction is your root. And when we simplify these expressions, so here's some examples here. If I have 27 to the 1/3, that's a cube root for 27. If I have negative 16 to the 1/2, that's the square root of negative 16. And then if I have a number on the top and the bottom of my exponent instead of just one, that would be that root. On the bottom number is your root, and your exponent would go for the top number. So here's an example of that. If I have 27 to the 2/3, then I have the cube root of 27 squared. How can I tell if I've simplified it as much as possible? An expression with rational exponents is simplified when all of the following conditions are met. No negative exponents, not a complex fraction, no exponents that are not positive integers in the denominator, so no negative exponents in the denominator, and the index of any remaining radical is the least number possible. So our root number has to be as small as we can possibly make it. So let's turn over and we'll look at our examples. So our first one is to write a to the 1/7 in radical form. And that just means that I have a to the 7th root. So that's all I have to do. And the second one, to write square root of w in exponential form, well, that would be w to the 1/2 power. So that's our root functions written as exponents and our fraction exponents written as root functions. So now we're going to look at some that are a little bit more complicated. What do I do if I have a negative exponent? Same thing we've always done with negative exponents, they become a positive fraction. So I have 1 over 4/9 to the 1/2. And I know that this is the same as saying the square root of 49, which is just going to give me 1 over 7. For the second one, we have two operations happening. We have the top part of our fraction, which is going to be an exponent, and then we have the 5, which is our root. So I have the 5th root of 32 squared. So I take the 5th root of 1024 and I get 4. So I just plug that into the calculator to find that. Simplifying some other expressions, here I have y to the 1/7 times by y to the 4/7. Our laws of exponents apply. So I have 1/7 plus 4/7, which equals y over 5 to the 7th. This next one, I have x to the negative 2/3. So we're going to follow that fraction rule again. 1 over x to the positive 2/3. And we don't want to leave that fraction in our denominator. So I think about how much do I need to add to this to make this even out? How can I make x to the 1? If I already have 2/3, I need 1/3 more. So I'm going to times both top and bottom by 1/3. And now I'm following that law of adding our exponents again, which will give me x 2/3 plus 1/3, which would be x to the 1, which is just x. So I have x to the 1/3 over x. That's the simplified version of this. So here's a couple different ones where we have different roots being combined. How can we combine these? So for the first one, we're going to break those up into our fraction form. I have 16 to the 1/6 over 2 to the 1/3 and now we're going to see if I can put 16 in the same form as the bottom into a 2. So 16 is equal to 2 to the 4th power. So I'm going to rewrite it as 2 to the 4th to the 1/6 and 2 to the 3rd. So it's equal to 2 to the 4/6 over 2 to the 1/3. It's a division rule of exponents, so we're going to subtract 4/6 minus 1/3, and 1/3 is actually equal to 2/6. We want them in the same form so we can subtract them. So that leaves me with 4/6 minus 2/6 is going to be 2/6, which I've already said is equal to 1/3 if we simplify. So now I just have cube root of 2. All right, for our next one, I'm going to break up as much as I can inside of my root. So I have 4 is 2 squared times by x to the 4th to the 1/6. So that gives me 2 to the 2/6 times by x to the 4/6. And I can simplify those both into thirds, 1/3 and 2/3. So now they're both cube root 2 and x squared. Okay, last one. So I have this fraction y1/2 plus 1 over y1/2 negative 1. We're doing something similar to what we did with complex numbers called a conjugate, where I multiply the top and bottom by the opposite of the bottom. So in this case, we're going to multiply both top and bottom by plus 1. So I have y1/2 plus 1, because down here is negative 1. We're doing the opposite, plus 1. And then you're basically doing the FOIL method for the top and the bottom. And what that's going to leave me with, I would have first would be y1/2 times by y1/2. So that's adding those two halves together, gives me y to the 1. And then I would have in the middle y1/2 plus y1/2. So I now have 2 y to the 1/2. And then at the end I have just 1. And the idea behind doing the